Let's look at the speed of light. So we know that light is an electromagnetic wave, and as such, it travels at a speed that's close to 3 times 10 to the 8th meters per second. Now, in the 19th century, there were several physicists who attempted to run experiments and measure the speed of light. Jean Foucault was a French physicist who used a rotating mirror to measure the speed of light. Albert Michelson, an American, was more successful than Foucault at determining the speed of light. He used an octagonal mirror, a rotating octagonal mirror, and ran the experiment over a range of 35 kilometers. So the octagonal mirror was set up on Mount San Antonio, and a plain mirror was 35 kilometers away on Mount Wilson in California. And what happened was that this octagonal mirror, this is a simplified version of the experiment, of course, but the octagonal mirror was rotating at a determined rate, and some light starting from a source was bounced off this octagonal mirror. It traveled 35 kilometers, hit the plane mirror, it bounced back, and while this rotated, another facet of the mirror encountered the wave at this point, and then it reflected it to an observer. So based on the fact that they knew the angular speed of the rotating mirror, they knew this distance and which of the facets of this octagonal mirror the light bounced off of, they were able to determine the speed of light. The value that Michelson obtained was 2.99796 plus or minus 0.00004 times 10 to the 8th meters per second, and that is very close to the accepted value, which is now defined to be this value. Now, it is so much more convenient to just use 3 times 10 to the 8th meters per second, since it's so close to the actual value that we will always use 3 times 10 to the 8th meters per second for the speed of light. So now is the time to talk about Maxwell's equation. First of all, James Clerk Maxwell was a Scottish physicist. He only lived 48 years, but his contribution to physics has been great. He realized that there is a relationship between electricity and magnetism, and also figured out how the different equations that we've learned, the different laws that we've learned in electricity and magnetism combined define electromagnetic fields, electricity and magnetism. So we call them Maxwell's equations. He basically organized some of the well-known equations that we've encountered, like the first one being Gauss's law, and we know that the sum of electric fields going through an area, so this is the electric flux, is charged enclosed by a closed Gaussian surface divided by epsilon naught, where epsilon naught is the permittivity of free space. Then there is another equation that we didn't discuss. It's called Gauss's law for magnetism, and it says that the magnetic flux is 0, and that is for magnetic monopoles. Basically, this law says that magnetic monopoles do not exist. We know that a magnet always has a north pole and a south pole. It doesn't just come in a north pole or just a south pole, and this is what this equation stands for. Then the third Maxwell's equation is Faraday's law of electromagnetic induction, that says that the EMF is the negative change in the magnetic flux with respect to time. And the fourth of Maxwell's equations is actually Ampere Maxwell Law. In this particular case, he did get a contribution to this equation. He determined that it wasn't complete enough. So what we know is that Ampere's law says that the magnetic field that's parallel to a loop is equal to the permeability of free space times the current enclosed by that loop. Well, Maxwell also determined that there was a contribution to that magnetic field from the change in electric flux with respect to time. So Maxwell actually did complete Ampere's law by adding this extra term to it. In 1865, Maxwell calculated the speed of light, and he determined that it was 1 over the square root of permeability of free space times permittivity of free space. So if we plug in the numbers for those, so permeability is 4 pi times 10 to the negative 7th Tesla meters per amp, and permittivity of free space is 8.854 times 10 to the negative 12th Coulomb squared divided by Newton meter squared. Then the value that you get is very close to 3 times 10 to the 8th meters per second. So we can thank Maxwell for actually calculating the speed of light based on electromagnetic waves and realizing that it is just a relationship between the permeability of free space and the permittivity of free space.